diagram is more than 1,000 blocks.
Yes, I can do it. You know what,
So bottom line is corresponding to a block actually, so it's a function block.
Little stuff in the block. You enlarge it.
It could be very difficult to create it by hand, but if you use Matlab, it's okay.
I use this block, and this is the LTI block. And I have 1,000 over here. I put parameters inside there, and I use
So you can change the parameters.
just add blocks and draw lines and set parameters. Do a for loop.
Okay. So in this way you can create complicated but easy to follow methods. Create the files to create the simulating model. The other topic is subsystems and block masking. This is also very useful in simulating modeling. So the question is why we need subsystems. If you have a very complicated system, if you have a controller which is described by an electronic device, operational amplifier, it could be very complicated. And you have a plant model which is given by something like mechanical systems. And if you draw all of these in the same window, you will see that they are far too complicated to recognize which is which. So the best way for this kind of problem is to group the controller together as one block and to group the plant as another block. And this is what is called the subsystems. So you can make the whole structure of the system easier. So in this way, we have to use subsystems. And how can we create a subsystem? Once you have a block diagram like this, so this is the motor. So if you want to create a subsystem of it, what you need to do is to select this area, select all the blocks in the area, and click the right mouse button, and you will see that there is one called Create Subsystem. So this part becomes a subsystem. If you double click it, then it will display the properties, the components in the subsystem. So you can use it. In this way, you can simplify the structure of the simulated model. So this is why we need the subsystems to extract models. And in this way, we can also create blocks, such as a PID controller. We can create one block as a subsystem. So another question is why we need to mask the blocks. Let's take the example of PID controller again. If you are using subsystems, if you are using subsystems, then this is a PID controller, this is another PID controller. You can use subsystems here and there. You can create a subsystem on PID controller, so you can use it here and there. But you must be very careful to use that, because if you use the same subsystem, then the parameters of the two controllers are the same. So this is obviously not the one we want. So how can we make these two subsystems independent? The best way is to use mask technique. So I do not have example code here. You can mask a subsystem. If you have a subsystem, then you right-click the mouse button. You can have a menu, and here there's one called mask subsystem. If you start mask the subsystem, then it allows you to change, to specify the parameters in the block. For instance, the KP, KI, and KD parameters. And you can follow the structures of mask subsystem, and you can create a block. Next time, when you use a PID controller, you can use the mask PID controller here and here. And if you want to change the parameters, then you double-click this PID controller, and you can change the parameters independently in this one. And if you want to change the parameter in that block, you double-click it, and with the dialog box, you can specify independently the PID controller in that block without affecting the other one. So sometimes you need to make mask blocks, and the thing is you can make the parameters independent of each other, and you can make it reusable. You can use it as many times as you use simulation. And sometimes you may find that if you have a very complicated system, if you want to draw the diagram by hand, it might be quite complicated. For instance, if there are loops or there is if clauses, conditional clauses, you may find that the implementation of such kind of model could be quite complicated. So the best way to solve that kind of problem is by the use of S functions. Here S functions stand for system functions. And the nature of S function is a description of state space models, either continuous state space models or discrete state space models. You can model it in this way. And the structure of S function is something like this. Well, we have an important flag here and input variable. And when the value of flag is assigned to 0, the value is assigned automatically by simulator. So if it is equal to 0, then we have to execute a piece of code for initialization of the model. If it is equal to 1, then the update in the state space model for continuous system is used. If lag equals to 2, then this kind of update in discrete time system is implemented. And if lag equals 3, then the output of the block is computed. So I'm not going to go into too much in detail on this topic. So I think that's all the topics I need to give today. Next time I will give a presentation on chapter 10, which is not the part of the examination. And then we will have a test, a final exam of the course. Are you sure that you can all bring the laptop computers? Is that okay, or is that okay? Or otherwise I can find the computer room. Which one is it? Okay. Just do that. So it's okay for today's class? Oh, yeah. I can make